there! I'm at Mathlock Mansion, an escape room where I'll have to solve the riddles in this room to get out. The first thing I have to do is figure out how to open this locked case. Can you help me out? There's a note attached to the case that says, to solve your situation, first solve these equations. There are 4 equations and it's a 4-digit lock. Oh, I see. We must solve these equations so we can use the solutions to open the lock. Okay, let's start with this first one. The first equation says a minus 9 equals negative 3. What does that mean? I know that in an equation, a solution is a number that when substituted for the variable makes the equation true. But how can I solve this? Right now, I know what the value of a minus 9 is, but I need to know the value of just a by itself. If I could get my equation to look like just a equals a number, that would do it. We call this isolating the variable because we want to get the variable by itself. How can I isolate this variable though? The equals sign in an equation tells us that both sides are equal or balanced, like a scale. It's our job to make sure that as we work with the equation, we keep it balanced. How do we keep both sides of an equation balanced? If we make any changes to the value of one side of the equation, we have to do the same thing to the other side. Just like this scale here. If I take away a blue triangle from the left, it unbalances the scale. But if I take away a blue triangle from both sides, they stay balanced and equivalent. With this in mind, let's take another look at that first equation. A minus 9 equals negative 3. I know I want to get this a isolated, but right now it's not by itself. It's being subtracted by 9. How can I undo subtracting by 9 to get this a by itself? Yeah, the inverse of subtracting 9 would be adding 9. Remember, to keep the equation balanced, if we add 9 to one side, we have to do it to the other side too. Pause the video here and add 9 to both sides of this equation now. When I add 9 to both sides, negative 3 plus 9 on the right makes 6. What does a minus 9 plus 9 make? Minus 9 and plus 9 are like terms, and when we combine them, they make 0. But there's no need to write a plus 0, so this leaves just a equals 6. Phew, we did it! That's the first equation down, but we still have 3 more to go to open the lock. Let's keep going. The next equation says 4m equals 28. Pause the video here and isolate m on your own now. The m is being multiplied by 4, so to isolate it, we need to undo that with the inverse operation, dividing by 4 on both sides of the equation. 28 divided by 4 makes 7, and 4m divided by 4 makes 1m, or just m. Now we can see the solution is m equals 7. We still have 2 equations left, and this one looks a little different. It says v minus 3 over 2 equals negative 1. I still want to get this v by itself, but how do I do that when it's in this big fraction? Well, what's happening to this v right now? It's being subtracted by 3 and divided by 2. Which one is happening to the v first? The order of operations tells us that groupings come first, and the numerator of a fraction is grouped together. So first, it's being subtracted by 3 in the numerator grouping, and then it's being divided by 2. How can we undo both of these operations? When there are multiple things happening to the variable, like we have here, we need to undo them in the reverse order of operations. That means first, we can undo dividing by 2 by multiplying both sides of the equation by 2. What happens when you multiply both sides by 2? Pause and try it on your own now. I'm going to rewrite my equation to give myself more room to write my work. Using parentheses like this helps show that we're multiplying this whole left side of the equation by 2, making 2 times v minus 3 over 2. 2 over 2 simplifies to 1, so this is v minus 3, and on the other side, negative 1 times 2 makes negative 2. Now that we've taken care of the dividing by 2, we can handle the minus 3. How can we undo subtracting 3? By adding 3 to both sides, which gives the solution v equals 1. This equation was a little trickier than the first two. I think we did everything right, but I'm not feeling quite as confident in this solution. My favorite thing about equations is that if I'm ever unsure like this, I can substitute my solution back into the original equation to make sure that it creates a true statement, like negative 1 equals negative 1. Now I know my answer is correct, so I don't have to worry. We have one equation left. K over 5 minus 4 equals negative 3. I think you're ready to try this one on your own. Remember, it can help to identify what's happening to K currently so that you can undo those operations in the reverse order. Pause the video and solve this equation now. There are two things happening to K. It's first being divided by 5 and then being subtracted by 4. What order will I undo those operations in? Yeah, to isolate K, I'm going to need to undo the subtraction first by adding 4 to both sides. Then I'll multiply both sides by 5. If you were stuck or had your operations backward, now is a great time to pause and try again on your own. I'll start solving by adding 4 to both sides, giving me K over 5 equals 1. Next, I'll undo dividing by 5 by multiplying by 5 on both sides, giving our solution K equals 5. Now that we've solved all 4 equations, let's see if their solutions open the lock. It worked! It looks like there are some pictures in the case. I don't know what they mean yet, though. Maybe another puzzle? Hopefully, we'll learn more after opening the next case, but we'll do that next time. Today, we got to explore solving equations together. The goal of solving equations is always to isolate the variable. To do that, we undo each of the operations happening to the variable in the reverse order of operations. Once you finish up your guided notes for today, you'll move on to levels 1 through 3 of the online practice. Until next time, remember, math is everywhere. Keep exploring it.